Okay, so gonna try this again. Hopefully this will work a little better than my last attempt that kept getting cut off here. I have a couple different maps I want to show real quick here. On one of the videos I mentioned where the name of the map was. And so here is the same map I was using in a couple other videos, but I wanted to make sure you knew that down in this southeast corner is where we get the name of the map, and the 1996, the field check date. Also kind of has examples of primary highway, secondary highway, light use roads are kind of done as this, unspecified, paved, gravel, dirt, hiking trails, four-wheel drive trails, things like that you can find on this bottom corner of your map. The name of the map is also visible on the northeast corner up here, Black Pyramid Mountain, and also tells us the state that it's in. So this covers both parts of Montana and Wyoming, and then also that it's a 7.5 minute series map. Like all four corners of the map, it gives us our latitude and longitude of that corner that it starts at. So this one is 109 degrees, 22 minutes, 30 seconds is our longitude. 45 degrees, 7 minutes, 30 seconds our latitude, how far from the equator up we are. So we're basically, that's telling us we're halfway between the equator and the North Pole, essentially, for the most part. As you move across, it has more information. These marks here, so we have 25 minutes right there. So we've basically gone the 109, 22, 30, 109, 25 minutes, 109, 27 minutes, 30 seconds, 109, 30 minutes. So we have our 2.5 minute distance between those. And likewise, it does that going north and south on our map. So we have 45 minutes, 45 degrees, 7 minutes, 30 seconds, 45 degrees, 5 minutes, and then we'll have 2.5 minutes, and then 45 degrees right there. So gives us a little bit of information. This southwest corner gives us some of that more information specific about the map datum, 1927-83, revised by the Forest Service in 1996. So it gives us more of that information down there. So the one thing I wanted to go over with this video is really getting a bearing and then following that bearing according to our map, and then getting a bearing from where you are to a certain point. And then plotting coordinates of something. So I know that other maps kind of did that, but some of it also got kind of cut out. So I'll just do it again, hopefully quickly here. But just kind of reiterate, here's our, tells us our declination. So on this map, 14 minutes. Magnetic north is 14 minutes east of true north. So we have an east declination. True north is to the west of magnetic north where we are. This is based off of 1997 magnetic north declination information. So there are current, you can go to USGS and find current up-to-date declination measurements. I feel like the most current is somewhere around 10 degrees actually. I know on this map that I printed off of National Geographic's topo maps was about a year ago, which puts it at 10 degrees. That declination just is October 14th of 2019, so 2 years ago, was 10 degrees off. Declination changes, magnetic north changes every year. It's constantly moving, so you always want to try and get as accurate as you can with that. But you want to make sure it's accurate with everything else that you're using. Plotting points. So I mentioned before, there's latitude, longitude, and UTM. Latitude, longitude uses these numbers, which can be more difficult to use. My preference, and most search and rescue and most agencies use UTM also. Latitude, longitude works well from up high. Airplanes, you'll hear use it a lot. But radio and coordinates back and forth to each other on the ground, UTM tends to be a little bit easier. So our UTM, it gives us that information over here on this southeast corner of our map. We have our 4,985,000 meters north of the equator, 626,000 meters east within the zone that we're in on the UTM grid. So as you move along, move up, we have 49,85,000, 49,86,000, 49,87,000, and it moves up. And each one of these, between these blue marks, is basically 1 kilometer. Going sideways is the same thing. There's a little blue mark under here, but there's the writing, so they didn't put a number. But we have 626,000. We would have, if we go to our west, that has more writing that's not UTM, but grid area. We come over a little more, we have 624,000, so it does have the blue mark. So we'd be at 624,000 meters east to 625,000, 626, 627, and at the corner, 628,000 meters east. So we get some good information there that helps us plot our UTM areas. I highly recommend, if you have or if you don't have, picking up a little UTM grid square here. Just a little clear piece of plastic with those numbers printed on there. And basically, if you take this, and they make them for, this is the 1 to 24,000, so 7.5 minute map. They make them for 15-minute maps and for other various scales. But I know my scale here, 1 to 24,000, and here I have 1 to 24,000. Each one of these small squares is 100 meters. And then the little dot in the center of it basically marks 50 meters by 50 meters. So you can get a little more precise information. But if we were to line this up with these blue hash marks, it allows us to say, for example, we have 623,000. I'll line this up. We'll say 623,100, 623,200, 300, 400, 500, 600, 700, 800, 623,900, and then that's right on the 624,000 mark. So it helps me trying to narrow down the specific locations. So it kind of does two things for me. If you have a map that has that UTM grid overlaid on top of it, it makes it really easy. For example, this map, this blue dotted line, is that UTM grid. So I can take my square and line it up inside of that blue dotted line. And I'm at 4973, 4974. And if I want to know what the actual UTM point is right here, then I can very easily go 1, 2, 3, 4, 5, 6. So I'm going to be 675,600 something by 4,973,000, 1, 2, 3, 400. So I'm between the 3 and the 400. So if I'm here, if I was right underneath of that dot, I would be at 4,973,350 meters by, if I come over, so I know this blue dotted line is 675,000, and it goes higher as I move to the east. So I'll go 675, 100, 675, 200, 300, 400, 500, 600, 700. So I think it was that dot, so 600. I'm on the 6 here. So this point right there is going to be 675,650 meters east by 4,973,350 meters north. So that little grid kind of helps you identify points real easy. It comes in handy in two different ways. So let's say I'm out in the field and I get a radio call that says that that they found something and need people to congregate at a certain coordinate point. I'm going to pick that coordinate point to be, and have a little, I'll look one up here real quick. I'm going to make my coordinate that I need to be at be 623.871 east by 4986500 north. So that's the point that I want to be at, where I'm supposed to rendezvous with the rest of the group, or where they want me to go to see what's there. Maybe an airplane saw something and they plotted that point. So I can find that information by trying to figure out where that point is. I know I'm at 623, or I'm more than 623, a little less than 624. So I have 623, 624. So the easiest thing is to take my little square and line it in here. So I'm going to be at 6238. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8. So I'm somewhere between the 8 and the 9 here. So I know I'm at 7, 1. Here's where 5 is. So 7 should be about there. So I can move my little piece of plastic and mark that, as that's where my east is going to be. I know I am 623,871 meters east, which should be on this line. Now that's going to be on that line anywhere north-south. These lines don't necessarily, depending on how on your map, always run straight north-south. This one is pretty darn close. You can kind of see here the distance between it, and then up here a little further. It's a little further out, but not by much, a tiny amount. So I'm basically going to try and line my ruler up so it's about the same distance from this line down here as it is here, as long as it's on that mark. So then I'm just going to take this and draw a line, and I should be somewhere on this pencil line. Now I could be anywhere from the equator to the North Pole. So I need to use my other number, the 4986500, to figure out how far north I need to go. So if I come over here, I know I'm 4986. Here's 4986. So I'm between 4986 and 4987. So again, I can line this up. And this tells me 4986500. So that's going to be really easy. So I'm going to go 4986, 1, 2, 3, 4, 5. And move that. I know that's the 500 mark. Draw a horizontal line going out this direction. And where these two lines cross is where I should be standing. That's where my point of 623.871 east by 4986500 north is. So that's that coordinate point. So that's one thing that we use all of this information for. The other would be if you need to figure out your coordinate, and you can say, oh, where am I? I've looked at my map, I've looked at my compass, I've triangulated a little bit, basically being I take my compass and I can look to my east and I can positively identify that lake. And probably realistically I won't, but I'm going to say that I can. I can positively identify it. And I'm going to line, well, I'm going to take my compass and I'm going to say to that lake is 280 degrees. So 280 degrees from where I'm standing to that lake. So I'm going to put my compass down, and my table is going to mess this up for me. But I'm going to draw a line that's 280. Then I can positively identify this lake. I can see that it's kind of boomerang shaped, and there's another little one behind it. From where I'm standing, it is 232 degrees. So I'm going to put this down. 232 degrees. So in theory, I'm standing right here, but it's triangulating, so I want to find a third one. And I can positively identify this rock outcrop here. I know I'm looking at my compass, I know where north and south is. That's straight south of where I am. And I do that. So I can line my compass up with it. Since my compass isn't long enough, I'm going to do a ruler. I'm going to draw a line, and I have this triangle here. Right there. I can make out where the lines cross, you guys may not. But it's right here, so I know I'm standing right at that point. So then you can use that same concept in reverse to figure out what your coordinate is, to have somebody, say a helicopter, come in, pick you and your patient up who are at this point right here. So to do that, and I kind of cheated, I already do it to a straight south line. So I'm going to draw a straight south line to the edge of my map, because I got to find these coordinates down here. I'm going to find one straight to the east-west. I'm going to follow this dotted line, because I know that stays more or less exactly east-west. Come over here. I'm going to take my little square, make sure I get it situated correctly. This line comes out here, so I'm just going to drop that in. And I'm going to say this comes up at 4,987, 1, 2, 3, 4, 5, 6. So I am 4,9,876. But I got two more numbers. And my line is just above that dot by a little bit. I don't think it's at a full another, it's at 60. So I'm going to generically say that's 55. It's a little bit of guesswork because this only gets so small. So again, 4,987, 4,9,871, 4,9,872, 4,9,873, 4,9,874, 4,9,875, 4,9,876. That dot is 4,9,875, and I'm just a little bit above that dot, so I'm going to call it 5 meters. Down here, you can do the same thing between 623, which actually is right there, and 622, or I'm sorry, 621. I'm going to line this up. And my line comes out right here. So I'm going to go 621, 621, 100, 621, 200, 621, 300, 400, 500, 600, 700, 800, 621, 900. Just so happens that that line lines up right on, you can barely see it under there, 629, 900. So I'm going to be 629, 900 east on that line. Tells me that this position right here, the coordinate for that position is 4,987,655 north by 629,900 east is where that is. So if I punch that into my GPS, I'm going to wind up, I'm going to tell my GPS to follow to take me to that point. It's going to take me right here. And again, I mentioned this before, as long as your GPS datum is the same as the datum on the map, it's going to show you the same thing. So you want to make sure you look down here and say North American datum of 1983 is shown by dashed corner ticks. So you want to make sure you're set up on your GPS to 1983 NAD. If you're set up to a different number, it might put you in a slightly different location. It won't be real far off, but it will be off, which may or may not make a huge difference. So hopefully that makes sense. Again, ask questions in the comments if you have them, or when we meet in person, we can practice this a little bit more, and then you can ask questions then.